Africa project is an initiative incubated by Code for Africa that looks at empowering citizens with the data from low-cost air quality, water and noise sensors. We've been fortunate enough to be able to deploy 68 air quality sensors across Nairobi, 1 sensor in Kisumu, so that's a total of 69 in Kenya. Across the continent, we have about 4 in Dar es Salaam, 1 in Kampala, and 3 in Lagos. Liquid Telecom will be providing us access to not only 3,000 of their sites across Nairobi, they're also providing Sigfox modules and access to the Sigfox network.
Sigfox have a great technology for low power devices that can communicate to the internet. They have what is a single global IoT network. They're in around nearly 50 countries now. By having a low frequency and having devices that communicate small data packets and they communicate less often, it is increasing the battery life of the device.
This allows us to be able to provide even lower bandwidth, lower power sensors to be able to then relay real-time air quality information like we weren't able to do before. I think those kind of applications that allow personalized, actionable information are going to be a big driver of IoT.
We've been leading on to how, as an operator, we can do more to enable IoT. We did a few IoT applications in Kenya a few years ago. We were working with the Kenya National Rally. They were having quite a lot of problems with poor quality timing and even a bit of cheating. We used VSAT solution Wi-Fi. We had timing gates and we had trackers in the cars. We did quite a lot for improving the quality of timing in Rally.
Liquid Telecom has deployed base stations for Sigfox communication across the country.
We've covered all of Nairobi, Mombasa, Kisumu, Nanyuki area, and pretty much covering large parts of the Rift Valley. We're increasing to sort of 85% of land coverage in Kenya, starting with all the main transport corridors and some of the agricultural heartlands of the countries, where we see some of the big applications.
We are a fish farming company based in Homa Bay County, Lake Victoria. We have a production capacity of about 300 tons. We are having a mix in real fish of cage technology and IoT technology. We have an innovation called Aquarage. Aquarage is a mobile app-based technology that basically is supposed to improve the productivity of small-scale fish farmers.
We work with real fish through a co-creation model where real fish as the fish farmer and developers at LakeHub came together to think through the process of fish farming in Lake Victoria and also around Kenya, because this intervention is targeting both cage farmers in the lake and pond farmers. And one of the things we realized is there are very important parameters for every fish farmer to measure. That determines how long the fish takes in the pond or in the cage, and also the cost of production. So this is water temperature, saturated oxygen, and the pH. So we thought about using sensors to communicate this information to the farmer. And the most viable way of doing this is if it can be accessed through a mobile phone. Hence, they need to develop a mobile app.
By using IoT and Sigfox technology combined, using the mobile app, once we are able to boost the productivity of fish farmers in the lake, we are then able to connect the produced fish to the women and fish traders who have relied on fish as a means of survival. Given that aquaculture is a key factor in the current government under the Big Four agenda on food security, we are hoping to leverage on that and provide technology to help farmers in this country achieve food security by enhancing production using the sensor and the mobile app.
We work with a lot of innovation hubs across Africa, and each country where we operate, we have one innovation hub we work with at a minimum. In Kenya, we've been keen to expand it out.
What we did here is that we brought in some internet capacity, and we also installed a few of the IoT base stations within the vicinity to make a good coverage, a redundant one at that.
For our technology lab, internet capacity is really key. Another thing we are working with them on is animal tracking, which is one of the projects we are exploring in the lab. So we have a few collars from them that we are going to deploy on cows. Naturally, we start with cows and then we can move on to other animal species.
We decided to pick up a solution that would actually not only work for us, but also be cost effective to the customers. In other instances, NB-IoT or any other IoT solutions, the customer sometimes needs to invest in the infrastructure. In this case, we have done the hard work, we've done the homework, and we've done all the internet working and the connectivity.
We want to see how many fixes we get. We want to see if they can withstand the weather. Our cattle are sprayed every 4 days, and we want to also see whether the collars can withstand the pressure from the spray races.
Within our mission of building Africa's digital future, it's in line with national policies and agendas. We're looking at things that are helping the Big Four agenda of Kenya. These applications are going to change the way we do business and change things in society.
So the Census Africa project is an initiative incubated by Codelab Africa that looks at empowering citizens with the data from low-cost air quality, water, and noise sensors. We've been fortunate enough to be able to deploy 68 air quality sensors across Nairobi, 1 sensor in Kisumu, so that's a total of 69 in Kenya. Across the continent, we have about 4 in Dar es Salaam, 1 in Kampala, and 3 in Lagos. Liquid Telecom will be providing us access to not only 3,000 of their sites across Nairobi, they're also providing Sigfox modules and access to the Sigfox network.
Sigfox have a great technology for low power devices that can communicate to the internet. They have what is a single global IoT network. They're in around nearly 50 countries now. By having a low frequency and having devices that communicate small data packets and they communicate less often, it is increasing the battery life of the device.
This allows us to be able to provide even lower bandwidth, lower power sensors to be able to then relay real-time air quality information like we weren't able to do before. I think those kind of applications that allow personalized, actionable information are going to be a big driver of IoT.
We've been leading on to how, as an operator, we can do more to enable IoT. We did a few IoT applications in Kenya a few years ago. We were working with Kenya National Rally. They were having quite a lot of problems with poor quality timing and even a bit of cheating. We used VSAT solution Wi-Fi. We had timing gates and we had trackers in the cars. We did quite a lot for improving the quality of timing in Rally.
Liquid Telecom has deployed base stations for Sigfox communication across the country.
We've covered all of Nairobi, Mombasa, Kisumu, Nanyuki area, and pretty much covering large parts of Rift Valley. We're increasing to sort of 85% of land coverage in Kenya, starting with all the main transport corridors and some of the agricultural heartlands of the countries, where we see some of the big applications.
We are a fish farming company based in Homa Bay County, Lake Victoria. We have a production capacity of about 300 tons. We are having a mix in real fish of cage technology and IoT technology. We have an innovation called Aquarage. Aquarage is a mobile app-based technology that basically is supposed to improve the productivity of small-scale fish farmers.
We work with RioFish through a co-creation model where RioFish as the fish farmer and developers at LakeHub came together to think through the process of fish farming in Lake Victoria and also around Kenya, because this intervention is targeting both cage farmers in the lake and pond farmers. And one of the things we realized is there are very important parameters for every fish farmer to measure. That determines how long the fish takes in the pond or in the cage, and also the cost of production. So this is water temperature, saturated oxygen, and the pH. So we thought about using sensors to communicate this information to the farmer. And the most viable way of doing this is if it can be accessed through a mobile phone. Hence, they need to develop a mobile app.
By using IoT and Sigfox technology combined, using the mobile app, once we are able to boost the productivity of fish farmers in the lake, we are then able to connect the produced fish to the women and fish traders who have relied on fish as a means of survival. Given that aquaculture is a key factor in the
Hello, everyone. Thank you for tuning in to the 4th edition of our virtual Firebase Study Jam. A big welcome to all of you, whether you're joining us from Zoom or from YouTube. Feel welcome. I hope you are taking care of yourselves at home. You are washing your hands, all the safety measures that we need to take into consideration to prevent us from getting the virus. So today's session is dubbed Firebase 0G and IoT. And we're going to learn how to integrate Sigfox network with Firebase with our instructors, Marvin Ngesa and Felix Omwansa. So basically what you are going to learn today is introduction to embedded systems, input output, digital analog, hardware and firmware, design process of an embedded system, the Sigfox Cloud, sending data to Sigfox database using cloud functions. I mean, you might be feeling like I'm talking like some bit of jargons, but throughout the session, I believe you will be able to get to understand what these terminologies actually mean. So a little bit of history or background information about our instructors. Also, our first instructor, that is Marvin Ngesa. He's an electrical engineer, a community organizer, a maker, and an educator. He has a great passion for interfacing connected electronics with software and artificial intelligence. Felix Omwansa is an electronics engineer serving as a technical solutions specialist for high impact applications across hardware and software. His key skills are designing and implementing a range of embedded solutions for industrial and consumer applications, use specific designs complete with internet connectivity for remote or local data transmission. So you can get to reach out to our instructor through their Twitter handles, that is at Ngesa254, and for Felix at Omwansa _. So yeah, I mean, I really want to take most of their time. I would just like for us to dive right into the session, and I hope you are going to learn. So yeah, stay focused and see you at the end. Remember to post your questions. If you have questions, I'll be sending in the link to the questions platform where you will be able to send in your questions and we'll be able to read them from there. That is the Slido platform. If you're not able to get the link, you can just go to your browser, slido.do, then join in using the ID hashtag 35084. I repeat, 35084, and then you're able to post your questions there. So yeah, thank you so much for joining us once again. Over to you, Marvin and Felix.
Thank you so much, Tabi. I think Felix will start.
Okay, you're welcome.
Oh, hi everyone. My name is Felix Omwansa. I hope you can hear me. Just have to do a quick audio check before we start. Thank you for the introduction, Tabi. I work as an Internet of Things solutions engineer for Liquid Telecom, and just as Tabi has introduced you to the segment, is that we are using our network infrastructure, our IoT specific network infrastructure to roll out different solutions for different use cases for different clients. And the whole idea is to build on the connectivity that is the regular people-to-people connectivity. Okay, just a moment of just switching on my video. Yes, so as I was saying, I hope you can see me, yeah. So as I was saying, as Liquid Telecom, we use our network infrastructure, which is the Sigfox network, to deploy various Internet of Things solutions. And today we're going to learn the end-to-end device and data journey that entails the whole IoT offering that is provided by Liquid Telecom. So just straight into it, I'm going to share my presentation with you. Okay, so straight off, in the exact same way that we have the Internet of Things, the Internet of People, rather, we do have also the Internet of Things. And the principles by which the connectivity is provided on both sides of the setup is pretty much the same, where we have at one point data being transmitted from a transmitter, and the other side data being received by a receiver. And the Internet of Things comprises of devices. In this case, this is what we are referring as to things. This is what we are referring as to objects. The Internet of Things comprises of these devices that have unique identities, and it is by these unique identities they're able to connect to the internet and send, or rather communicate, whatever they've been designed to communicate. And a key, of course, out of that now comes out that the focus in the Internet of Things is in remote monitoring, is in remote configuration and remote control, and general networking via the internet. And we'll get to see how different the Internet of Things is from the Internet of People. And straight into it is the solutions provided by the Internet of Things are based on real problems, rather. And it is our understanding of these real problems that we are able to formulate these solutions. And in our comparison of the Internet of Things to the Internet of People, we find that the connectivity requirements, the complexity of communication is much different for both cases, in this case things and for people, where you find with people where you use your Twitter, you use your Instagram, you are streaming this on YouTube, you are streaming this on Zoom, we have a higher bandwidth requirement, and it is this is a key difference with the Internet of Things, where these things, these objects are simply meant to perform specific tasks as compared to the complex tasks that your devices use, your mobile phone, your computer use. And for this reason, we find that the design process that goes into making these devices is based on a profile that enables that remote, that cost-effective, and high battery life design that goes into these devices. And these constraints really define the form, the physical form in which the devices will take, and also the virtual form, in this case, the kind of information they'll be transmitting, where having specific tasks or being designed for specific tasks, the Internet of Things devices send low bandwidth messages, or rather low size messages. And for this reason, we they are required to have a high battery autonomy, meaning that they need to last as long as possible from when they are deployed in the solution up to a further future, which may be 3 years, 4 years down the line. And then these factors in this battery life is factored in, of course, just as I mentioned, the connectivity. And that goes into the number of messages the devices will be sending. Say you could be sending two messages per day. You could be sending 10 messages per day. You could be sending 100 messages per day. And then, of course, given the remote aspect in the applications that we find the Internet of Things, there needs to be a high communication range, and that goes into building a huge reliability of the network that this Internet of Things devices will use. And for that reason, we find that these applications that the Internet of Things is going to solve, or rather solves, is time-critical applications where real-time information is required. And this real-time monitoring is what brings out the value, is what brings out the advantages, or rather the solution offering brought about by the Internet of Things. And that being said, low message sizes, high battery life, high environmental ruggedness, or rather physicality, is what then goes on to drive the cost of these devices low enough, and for them to be deployed at a mass scale that they are required. And now moving on into some few aspects of the kind of network technologies applied for the Internet of Things, is that, like I've mentioned, the applications that we find Internet of Things are not conventionally associated with the internet. This means that we are applying connectivity to real world applications, real world scenarios where connectivity hasn't really been a part of the conventional system. And that just drives into my point of saying that we are making dumb things smart. We are enabling things to communicate remotely and reliably. And Internet of Things networks, which will be covered as we go on in today's session, they're designed to meet the constraints for these things, which of course goes into the high battery life. How are these networks ensuring a high battery life? How are these networks ensuring that we have a compact message sizes that can be transmitted easily and for long distances, for longer ranges? And then again, how are these networks been optimized to be as low cost as possible, that they do not require the complexity, or rather the cost implications that regular networks that you and me use as the Internet of People? And just now digging into embedded systems is it's what now refers to the extreme edge, one extreme edge of the Internet of Things. And given the context of this study jam, we are using Firebase tools, Google Firebase tools, to build web services, to do data administration, to do data analysis, to build web apps, to build Android apps. And that context really culminates at the other extreme edge of the Internet of Things, where this data is being sent to. And embedded systems, what they do is that they are application-specific computers, under very constrained resources, in terms of space, under very constrained resources in terms of network connectivity. And it is under these constrained resources that they perform very specific tasks. And embedded systems, or rather embedded devices, have their core basic concepts. And this is what is just highlighted on a very high level in this slide, where I'm talking about I/O, input and output concepts, where this just refers to the direction of information flowing into our system or out of our system. Digital and analog concepts, we have a representation of these physical parameters that these things are monitoring. This representation is done in a digital form, is done in an analog form, and that then translates to an analog to digital conversion that may be required, and a digital to analog conversion that may be required to with regards to the direction of information that is flowing into and out of our system. And at the very basic level of embedded devices is that we have the hardware meaning the specific electronic components that have been networked together, and the firmware meaning the software that enables the activity that is the hardware. So the design process of an embedded system entails the interpretation of real world problems into solutions. And we will get to see how this happens. So a general form of Internet of Things hardware can be seen in this block diagram, where we have a profile of having a central processing unit that is labeled as the microcontroller, the central part. And this profile then outlines that we need to have a power source that will be supplying power to the entire system. And we need to have external memory. Well, that, or maybe on that could be an external memory or internal memory that is within the microcontroller. But then again, we find the flow of information being bidirectional. And then we have the transceiver. And now the transceiver now simply is the communications part. And this goes on to address that aspect of remote, or rather smart connectivity of hardware, where we have hardware that is performing specific tasks, but besides performing the specific task, is able to communicate the kinds of data it's able to collect. And besides that, we have the other interfaces, and we see that sensors drive information into our system. So this generally is a general outline on what you would expect on a hardware, on a basic hardware level, what kind of system would have to be implemented to enable a hardware device to communicate. And going a bit deeper now into an example system. As you can see now from the same, borrowing from the previous profile of a microcontroller and the power sources and transceiver, the external memory and the sensor interfaces, we have such a system being implemented on this slide. And as you can see, we have the main power supply grid that supplies various levels of power into the system. 3 volts, we have 3.3 volts, we have 2.2 volts, we have 5 volts. And this is transferred, this power supply is like the basis that drives, or rather keeps the system, is the heartbeat of the system, is what keeps the system alive. And as you can see, it's for that reason that you have the power supply lines, the power supply grid being fed into all the other functional blocks of our system. And you have the power supply going into the sensors, you have the temperature sensor, the humidity sensor, the motion sensor, etc. And we have our communications, which was the transceiver. In this case, will be our Wi-Fi, the big red indicator at the top. And then closer to the other side, we have some few other components of our systems, an LED indicator and an alarm. And then the next slide, or rather the next block, simply goes on to outline the kind of essence, or rather the value or the specification that we have for our IoT devices. And in this case, we have sensors that are monitoring temperature, monitoring humidity, monitoring motion, monitoring proximity, monitoring location, monitoring the light intensity. And all this information is what we are interested as the value point of why we are having IoT. And just to iterate, rather to go again or to repeat myself about our discussion, we are at the extreme edge. We are at the far edge of this data, and we've started discussing. We've already started discussing how these devices that can collect this information would be transmitting. And the transmission, or rather the actual point of transmission or information collection and transmission, is what an embedded system is what an embedded system is rather. And yeah, so the solution design process for Internet of Things devices takes a general form of course, the assembly of the physical hardware. This physical hardware being the main components, or rather the use-specific components required for our device. And then we would move on to device programming. And this then introduces concepts of interfacing, where our system will be, or rather our central processing system is interfaced to various inputs and outputs, in this case, our sensors that will be connecting the data. And then the data administration, or rather before the data administration, the telemetry. Telemetry simply refers to the communication, or rather the remote transmission of this information that the devices are collecting. And then from that point, after the device information has been transmitted remotely via the network, it gets to a point where it's administrated. We get the databases, we have the structured, this non-SQL or SQL databases, in whatever form the software engineer will be designing the data administration point of this data. And then before now, we get to the user. The user will be interested in seeing value in the data, will be interested in seeing charts, will be interested in seeing line graphs, will be interested in seeing comparison, will be interested in seeing analytics. And this is what we are referring to as the visualization process. And hardware design setup, or rather tool setup, of course, goes into the physical hardware design tools that you'll be using, and of course the software design tools that you'll be using. And I've just mentioned a few off the top of that, where the CAD tools, the computer-aided tools, are the ones, the software you will be using to implement the hardware design specifications, or of the physical form of how the hardware is going to take. And the IDE, by the IDE, I'm just referring to the programming environment that you will be developing the firmware that will be resting on the hardware, that will be running on the hardware. So the programming knowledge that is required for our use spans across various languages, and then again isn't limited to how, or rather, your own background skills, so to speak. And then so for our demonstration today, we will be seeing a Sigfox device. And just before we get into understanding the transmission, we are going to discuss the Sigfox network, how this particular device will be transmitting its information into the Sigfox Cloud. So a little context about this device. It's what we developers would refer to as a dev kit, or rather, a dev board, and it's simply a tool that you can use, or rather, it is a programmable tool that you can use to quickly prototype the various kinds of solutions you want to develop for your Internet of Things. And the most crucial part about this device, of course, is that it has the connectivity, the Sigfox connectivity. And as you can see from the images, there is an image with a black antenna connected into the device. So that just goes to tell you that this is a communication-ready device that you can use. And the reason I'm blowing it up for you today is, I'm showing it up for you today rather, is for you to be able to have a view of the contents that this device has. And it has an array of sensors. And maybe just for your own viewing, you'll get to see that it has a microphone, it has a 3-axis accelerometer, it has a temperature and humidity sensor, it has a light sensor, and it also has a GPS module for getting location information. And then again, besides that, it has the connectivity, which is the Sigfox radio communication part. And the same this device follows the profile that we've just covered of a general IoT hardware, where we have a power source, the device having a specified power source that supplies life into the entire system. And we have the central processing core that is connected, or rather interfaced, to the communications module, and also to external memory, and also to other sensor interfaces. And this device is what is an actual implementation of what an IoT device would look like, where it really comes down to the designer, what the designer is interested in sensing, in monitoring, in reporting information about, and that information isn't limited to just one sensor. And for that reason is why we have IoT devices having an assortment of different sensors, and whose information describes what that device will be doing. So case in point, maybe case in point is that you could think of a dairy company. Company that maybe trade products like yogurt, transports ice, sensitive goods, and this company would like to keep track of these goods as they move from pickup point to destination. And besides tracking the goods, the company might also want to monitor the temperature conditions that the goods are experiencing. So you see, you'd think that, or rather you'd know that sensitive products like food products would require cold temperatures to enable them to last as long as possible. And so this company would require to track the vehicle, and besides that, get the information about the temperature conditions that these goods being transported are being exposed to. And that just drives my point on the complexity that can be applied into an Internet of Things device. And just a quick look into the profile. We have the power supply, which is represented by the lithium or potassium battery port on your left, or could be the micro USB port, as you will see in a moment. Then we have the 64 megabytes of flash memory. That's the external memory. We have the STM32L and Sigfox the bit at the center. That is the main processing core. Then we have the rest of the sensors and the other outputs. So this is just a general view. That was just a general view of what goes into IoT hardware. And now, perhaps for the context of our study jam, that we are finding, or rather we are learning about tools on how to manipulate this information, how to visualize this information, how to analyze this information. And the most important part, of course, is the byte, is the payload, the message that these IoT devices send. And so in this slide, you will get to see a definition, the message packaging of our Internet of Things. As you can see, this message, every message that is sent by an IoT device is unique in its own respect, and it is for this reason that we have various parts of the message representing various elements that the device could be measuring, the device could be sensing. And you can see from the byte breakdown from the tables, we have various bytes, 3 bytes for latitude, we have 3 bytes for longitude, we have a byte for light percentage, light intensity, and then we have a whole other range of sensor data that is transmitted by the device. So that represents the point at which the hardware, rather the hardware is described, where we have the hardware, our hardware devices collecting information and packaging this information, as you can see from this payload description, packaging this information into a form that it is transmitted into the network. And yeah, so that's it from me. that's it from my side today. I hope I've been able to cover the main core elements that were of interest for this session. And yeah, so I'll hand it back over to Marvin. Marvin, please resume.
Yeah, so thank you so much, Felix. Let me just get my deck and then I get started. Okay. Yeah, so once again, thank you so much, Felix. Get my things here. Okay, nice. So yeah, I'm going to continue from where Felix left, and I'm going to basically connect 0G, or rather Sigfox, and with Firebase. Once again, my name is Ngesa Marvin, and I am an engineer at Liquid Telecom. So I'm very passionate about connecting sensors and then using them with embedded systems, and then also enabling them to be able to send data to a cloud platform where you can be able to analyze them and draw meaningful information from them. So on the one for Firebase, you have a Sigfox device which sends data from a remote location, and then you're able to create an endpoint which could manage this data and then send it to a real-time database. So ideally, what I'm going to cover is how Firebase Cloud Functions are able to receive data from remote locations and then push it to real-time database. So just to reiterate what Felix said, Sigfox is basically a dedicated connectivity for things to be able to communicate with each other. It's a dedicated network for IoT devices to be able to send small messages from very, very wide distances to a network. And then the network grab the data and then send it to a cloud location. So we already have other networks, but why are we using Sigfox? Why are we using Sigfox to send this data all the way to Firebase? So Sigfox ideally enable you to be able to use devices which consume the least amount of power. And as you know, most IoT devices require low amount of power, because sometimes these devices may be in very far locations, in farms, they may be on trucks, and you don't need to kind of charge them over and over again. So this network allows these devices to be able to send information using the least amount of power. And other devices could stay in the field, or they could stay in the environment for as long as 5 to 16 years. This network also enables these devices to be able to have the best indoor penetration, such that if you have a water meter at the deepest end of the building, then still with the network, the devices will still be able to send the data from these locations. And with those properties, the low power of the device, the low cost, the wide area network basically classify this network as a low power area network. And on this graph, you can see that I have energy cost efficiency, and then also I have scale. So for example, if you're using 4G or 3G, or let's say 2G, for example, they may consume more power compared to what the devices under this area consumes. They may give you a bigger bandwidth, but then you realize that most IoT devices, sometimes they just want to whisper in the network. Sometimes they don't want to send this huge amount of information or send this video to the internet. They just want to whisper that this is my temperature and this is my humidity. So we feel that it's really important for these IoT devices to be able to use the least amount of power and to be able to send data at a very long range. And then they also need to be at a lower cost. So we have the network across the country. In fact, it's almost covering 85% of the Kenyan population. What I'm showing you is an actual map, which we took, I think, 2 months ago. And in this map, the red part basically indicates that we have at least 3 base stations covering the area. And the green part means that we have at least 2 base stations covering the area, while the blue part means that we have at least 1 base station covering those areas. So there is a good network in the country, and it basically means that any IoT engineer or any person who want to build an IoT solution, or any person who want to deploy IoT devices, they could easily leverage on top of this network and use the network for their benefit. And this network basically allow different use cases. They allow people to be able to track their devices. They allow people to be able to do smart parking. They enable people to be able to monitor oil level and tank level, people to monitor waste level. They also enable people to be able to know the humidity and enable them to be able to do smart irrigation in their farms. Other people are in fact using it to monitor air conditions, the air quality conditions of different cities, and advising the authorities. And also other people are using it in swimming pool and smoke detectors. So what I'm showing you, in fact, is a map of a truck which was moving from Bungoma all the way to Nairobi. And they had a 0G device, a Sigfox device, which was sending latitude, longitude information about the truck and about the cargo inside the truck. And we were able to plot this data on a platform and be able to know in almost real time where the truck is. And the second one also is for another customer, where they want to know the conditions of their farm. Most of the time, you realize that a bunch of people who are in agriculture, they just put manure in the same place, in the same farm. So this particular device will be able to let you know the amount of humidity, the amount of ambient temperature, the speed of wind, and the amount of rainfall in this particular location, plus other devices which are in the soil. And they could guide you on when to irrigate, because sometimes it's very windy and you are constantly sprinkling the farms. And this way you may be wasting the water. And also most of the time, this water is normally mixed with chemicals. And when you waste the water, you also waste the chemicals. But if you have these IoT devices, they could easily grab this data from the farm, grab the data about the environment, and be able to enable you to make good decisions about your farm and about when to irrigate, and also when to add manure, etc. And also other guys are using them in tracking the amount of water they're using. These are some of the devices that we are installed. And this is an example of a platform where you're able to know, you're able to get the alarms from the farm, or you're able to get alarms from a particular water meter. And you're able to know if there is a leakage. You're able to know if there is a burst in your pipes. You're able to know if there is a reversal in the meter. And also, most importantly, you're also able to know the amount of water you're consuming in your house. Are you consuming more water than you need, or is it less than the amount that you're supposed to consume? And this one can easily help the authorities to be able to give bills to people. Because most of the time, we just have people coming to your house and then they do the readings about the meter. And sometimes the person being billed and the person collecting the data, they're not in agreement about the readings of the meter. But with this type of meters, you can easily get data from the device all the way to a cloud and to a mobile app, and both the client and the user and also the water authorities are able to be in agreement about the amount of water that a particular client is using. So Felix, I've talked to you about the devices, basically what you see on my left side. And you have several devices, basically anything that has the ability to communicate using Sigfox network. And these devices, they just whisper about the environment. They whisper about the amount of water consumed. They whisper about the weather. They whisper about the conditions of cargo, the conditions of goods being transported from one location to another. And then there are the bunch of antennas across the country which are just listening to these devices. And when they get this information, when they get this data, they automatically forward them to a Sigfox Cloud. But before they forward it, they ensure that this data is correct, this data is secure, and this data is from an IoT device. And once it's on cloud, then you can always add an endpoint. You can always add something which we call a callback, an endpoints, so that when we get the data from the device, we automatically push it to a server like Firebase or a real-time database like Firebase. And once it's on Firebase, then you can grab it and put it on a platform. So Felix has handled this particular part, and I'm going to pick it from the cloud all the way to Firebase and to dashboard. And at the end of this session, we hope that we're going to be able to do a demo where Felix is going to remotely turn on his device, and the device is going to send data all the way to cloud. And I'm going to create an endpoint which is going to listen to triggers from Firebase, from Sigfox, and the endpoint is going to manage the data from the device and get to know the particulars of the information that is being sent, and then we're going to see it on the Firebase dashboard. And as you all know, Firebase is basically a backend tool that allow you to be able to write your functions, and that allows you to be able to do your backend without worrying about managing your servers and also security about your servers. And Firebase can allow you to be able to, can enable you to be able to do things like authentication, build cloud functions, do cloud firestore and storage, and a bunch of things. And I believe that these ones have been discussed in the previous sessions, and I'm just going to focus on the connection between Sigfox Cloud and Firebase. So, so cloud functions, they're basically functions that could listen to triggers from different things on cloud, like storage, authentication, firestore, and also HTTP endpoints. And once they get those triggers, they're able to get objects from the origin of the request. They're able to get the properties of the request object. And once they get these properties, they're able to handle the data and then store it on a particular location. So I don't really want to do much of deck. I just want to go to my code direct. So let's try it out. Yeah, so the first thing that we're going to do is to install Firebase tools. And I've already installed Firebase tools, but if you want to do it, you could just do, I think I'd started this already. You could just do npm, let me just write it here. You could just do, let me go here. You could just do npm install globally, and then Firebase tools. Firebase tools, but I've already done this one and I don't want to do it again. And then I started doing this one so that in case my internet doesn't behave, I'm still able to do the session. So I just confirmed the version of my Firebase, and it's always a good idea to improve the version to have the latest version of Firebase. And then I've logged into this account using Firebase login. So you can always log in, log out, and use the account that you need. Then after this, let me share another screen again. Do this, and then share. Share. Yeah, so let me just go to Firebase. And then the first thing you're going to do is to create a Firebase project from this point. I've already created this, but then let's see the one I'm having here. Okay. Yeah. So you can just go ahead and do create a project, then GDG, let's say toot, and then just click continue. The good thing is that it gives you step by step on how to go through it. I don't really need to enable, I don't have to enable this Google Analytics for this project. Then I just go create, and then it will take some few seconds to create the project. So as it does that, let me go back to the other screen. It is it? Yeah, so as it does that, I've also run Firebase init functions so that I'm able to access I'm able to create the Firebase functions project, and then I've installed some tools, and then it will ask me to select the project that I want. So I've already selected, I've already used this option to use an existing project because I don't want to create a new one. I've already created it on the platform, on the dashboard on the other side. So I'm going to just use this GDG toot to use it. Just going to click OK. Hope it won't take a long time to install. Then I'm going to use JavaScript, and then definitely I need that. And yes, I want to install the dependencies now. So as you can see, as it installs all this, you can see that there's some changes on my file on this other side. And once it finishes, you'll see that there are also some new changes on it. So as it installs, maybe I could fire up my Postman, because once we have the endpoint, we need to test it. We need to test the endpoint and see that we're able to do we're able to do the request and get the response from the request. In the meantime, I could take questions. Seeing that Ian is raising his hand. So let me just go to this point and take some questions. Yes, Ian. Let me see. I think almost connection. Yeah, so as it installs, probably I could just touch on this part. I think I have some of the main things here. So on the project structure, you're going to see that we have a folder called functions, and inside these functions we have node modules, and also we have index.js. So I'm going to remove all this. And then with I'm just buying time so that this can finish. But then this is the name of the endpoint, or rather this is the name of the cloud functions we're going to deploy on Firebase. And then I have this one to register the triggers. And normally, okay, let me see. Awesome. Okay, let me see. Okay, I think this is done. So normally this event handler, it takes two objects. It takes two properties. One is the request object and the other one is the response object. And this request object, it's going to enable us to be able to access the properties of the original HTTP trigger from the client. And it's going to enable us to access data from the client side and then handle that data. While this response object, it's going to enable us to be able to send feedback back to the client if it's okay or if it's not okay. And then I'm just going to do my plans here, where the first thing I'm going to do is to get the data. And then secondly, I'm going to manage the data. And then thirdly, I'm going to send this data to Firebase. So to get the data, I'm just going to do that. And then I'm going to use that object. And then once I have the data, I want to manage it. And to manage it, there's a function I've already written to convert the data that we got from that we're going to get from Felix. I think the function is somewhere here, and I'm just going to grab it and bring it in this functions folder. Okay. Yeah. So yeah, so I'm going to use this function to be able to manage for me the data that I'm going to get from Felix. And once I have the data, then I'm going to have an object which I'm going to save on Firebase. So let me just go back to this, and then I need to import that module. So I'm going to use this decoded, and then once I have the decoded, then I'm going to grab this data and put it here. Then I also want to just know what I'm having on this data. Yeah, I think I need to have this one here. So the request object gets the data. Then I could get data. I could grab that data from this one, and then I'm logging it at this point. Then once I have the data, I'm going to use a function to be able to manage this particular data, because normally the data is encoded, and sometimes it could be in hex, and then sometimes also someone can have an encryption on top of this hex. So when you get this data, you need to remove the encryption and then decode the data. So, but luckily this one doesn't have the encryption. I'm just going to receive the payload from Felix, and then slice them, and then finally have an object, which I'm going to return back to my Firebase function. So once I have this one, then I want to send this data to Firebase. But before I send it, I need to get the Firebase SDK. So I'm just going to do that, then get the module, require Firebase admin. Then once I do this, then I need to initialize it. Initialize app. Yeah. Then once I initialize it, then this basically means that I'm able to use this library to be able to send the data that I'm getting from that have been decoded and send it to Firebase. So from this point, I'm going to use that admin, and then I think I'm going to grab database like that. Then I'm going to get a reference where I'm taking this data to, and I want to save it at GDG, say GDG toot. Then after that, I want to push this object now to Firebase. I'm just going to put it there. Then once I push it, I need to return a promise. To just say that that it's okay, it's been pushed, the message has been pushed successfully. So just going to do that. And if there's an error, then yeah, then I think this should be okay. First, I'm getting the library from Firebase functions, which I'm using to create my functions. And with these functions, then I'm using this one to register my endpoint. And all these ones, all this event handler gives me two parameters. I have request and I have response. And with this request, I'm able to get the parameters from the original HTTP request from the client. And I'm basically able to get data from that one. And from this data, I'm also able to log it on the screen. And then this data, normally it's in hex, and sometimes you have encoding, and then you have encryption on top of it. So the first thing I'm going to do to this data is to handle it, basically just manage the payload. And then once I manage the payload, I'll get meaning out of it. And that's what I'm going to return. Then once I get it back, then I'm going to send this object now all the way to Firebase real-time database. And then, yeah, this is the reference when I'm sending the data to, and this is the object. And then I return a promise if the message is successful. And then if there's an error, I also send the error. So I think this is okay. So let's see this again. So, okay. And then as it deploys, probably I could check if we have questions here. Yeah, so it's taking some time to deploy, but soon I think we'll have the functions online. Yeah, so it's complete. And when it's done, then it's going to give you an endpoint at this particular point, which you should use. So I'm going to test this endpoint on Postman and see if it's working as expected. So you can always use Firebase deploy, but also if you want to run it locally, you could do Firebase serve. So let me share my Postman, then we give it a yeah. So this is Postman, and then I have the data that you're basically going to grab from the request object, and these are sample data that I want to test, and then I need to get a response from it. So let's see. Okay, then good. Yeah. So so that has been added, and let's see the same on Firebase. Yeah, so I have this one. Then let me just see the logs from it. Yeah, so basically this is the dashboard for the app that you're building. And from that dashboard, you should be able to see the function that you've created from this other side. And this is the name of the function and the URL on it. And then also, you should be able to get the logs from that particular function. So let me just open it. Yeah, and from this log, you can see that this is the data that I've sent. And from this data, I've run a code that manages the data. And once it manages the data, I'm able to get the object which I'm taking to cloud. And this object basically include latitude, longitude, temperature, and humidity. And then if I go to Firebase database, because I was storing the data there, then should be able to see something on it. Yeah, and then if I go to Firebase database, you can see that I have this data there at the same time. Yeah, so from this point, I think I'm going to go to Sigfox backend, and then Felix is going to put his device on, and then we're going to see if we're able to receive the data all the way to Firebase. So I'm just going to Sigfox backend. Felix, please share with me the ID of your device.
Hi, Marvin.
Hi, Felix. Please share with me the ID of the device you're using.
Yeah, so BE.
Okay, BE.
Capital B.
Yeah.
8068.
Okay, 8068. I think it's this one. Yeah, so I think, so this is the device that Felix is having, and I'm going to go to its device type. And normally in the Sigfox backend, the cloud normally give you 3 options to access the cloud. One way is through a web platform like this one. And the second way is through using something called an API, which is normally at the group level. So if I go to this Sigfox group level, then I can always access the same data that I'm accessing through this web portal through an API. And the other way is through using something called a callback. At the moment, I'm just going to use a callback. So this platform also enables you to be able to see devices, to be able to see different groups. Yeah, so let me just go to callback. And then from this callback, I'm going to create a new one. And normally you have 2 types of callback. One is something called a custom callback, and the other one is something called a built-in callback. So there are other companies which already Sigfox and Link Telecom has already been working with, and they've integrated their cloud platforms directly to the cloud. But then also anyone having a server, anyone having an endpoint could always come to custom callback and then choose the type that they're using, choose the channel. And I don't want to put anything on the payload configuration because I already have a file that manages for me the data that I'm receiving from this backend. And I was given a URL, which I'm just going to copy from, let's copy it. And then I'm going to add it here. Yeah, so this is the URL. And then also I'm going to do a post request to this endpoint. And I'm not going to have any headers. And the content type is just JSON. And I don't want to send a lot of things. I just want to send the data. Data, then data. So this is what I want to send. So let me just save it. Then we go check on the Sigfox on the Firebase end. Yeah, so I have that. Let me just check here. Yeah. So yes, so I already have an endpoint here. So basically what's going to happen is that when Sigfox receive the data from the device that Felix is having, we're going to automatically do a post request to that endpoint, which I've created during this session. And this endpoint is going to manage the data and then bring it to Firebase real-time database. So I'm going to ask Felix to turn his device on. And then we're going to check if they're coming on the logs. So Felix, please turn the device on.
It's on actually.
Ah, okay.
You could stop sharing. Maybe I share video of the device.
Okay. So yes, please share the video of the device.
Let me know once you can see it.
I can see it, Felix.